This is Bill Koenig of SME's Advanced Manufacturing Media and Manufacturing Engineering Magazine, and we're with Greg Morris of GE Aviation, and thanks for dropping by. As a way of kind of easing into it, during the keynote yesterday, a GE executive talked about how you at GE Aviation, and specifically the company they acquired, were early adopters of 3D printing and additive manufacturing. I wonder if you could just walk us through how that developed.
Sure. So thanks, Bill. So we actually started our journey way back in 1994. We were involved primarily in the polymer space and eventually led into the metal space in 2003 when we were the first company in North America to bring over the powder bed laser-based technologies. Long short of it is, I think that once we had that technology in place, we started to leverage it to build some pretty unique geometries, and actually one of our first customers was GE Aviation. So on that journey, we were working with the fuel nozzle design, and at that time there was a lot of know-how we had developed internally that they didn't have, and decided, I think, ultimately that in order to secure that IP for their LEAP engine, that they felt it would be most beneficial to acquire our companies, Morris Technologies and RQM. So by virtue of that, having that intellectual property, having around 21 metal machines at the time, I think GE said this is a great space for us to be involved in, helps us secure the LEAP engine supply chain for at least the fuel nozzle component. And I think at some point they also believed that there was additional disruptions to come, and of course that's played out as we've moved forward. So that's how we got involved in the technology from the very beginning, but also how we came into GE, and since that time we've started to apply it in a variety of areas.
Once you became part of GE, how did you sort of communicate that there's a lot more than fuel nozzles you can do with additive?
Sure. So, I think one of the areas that we really used the technology heavily on was in prototyping, and that was prototyping for the fuel nozzles. But of course, once the fuel nozzle path was well on its way, we started to get more involved in other components around gas turbine engine parts. So those gas turbine engine parts became prototype parts that we started to produce, not just in the combustion chamber, but also in other parts of the engine. And of course, that led to people thinking a little bit differently about how do we use the technology, how do we take this technology beyond just a part level, how do we start thinking about it on a system level. And really a turning point for us internally at GE was when we took one of our smaller engines, we made it an R&D engine basically, and a white sheet of paper, and said let's go ahead and take this helicopter engine, redesign it with additive in mind, and try to see how many parts we can actually make in additive. And as it turns out, we were able to make well over 50% of those components in additive, test that engine in record time, and basically demonstrate that the technology was far beyond capable of not just fuel nozzles, but involved in other parts of the engine. That has since led to the advanced turboprop engine, which now has 35% of that engine that will be 3D printed in a production basis.
Aerospace and aviation has a particular interest in additive possibilities for weight reduction and thus making aircraft more fuel efficient, and also geometries, new ways of designing. Can you sum up just what it is about additive that makes it such a good match with aerospace?
Sure. So I think there's some really natural fits. First off, I would tell you, at least on the metal side of it, and this also goes into the polymers and perhaps other materials as well, is that aerospace deals with very exotic materials, high-end materials. So we're talking about things that are Inconel-based. We're talking about things that are nickel-based and titaniums, aluminums. So these are the type of materials, and then you further that with the geometries, which are also very complex. So you have a really natural fit for a gas turbine engine component, having high alloys, having a unique geometry. It just makes it a great fit for that particular industry. The volumes would be kind of the third leg of that stool, so we're not talking millions of parts, we're talking generally much lower quantity of parts, and as the technologies exist today, and historically, it is made for a very natural fit.
In aerospace, they have what they call the fly-to-buy ratio, and in some cases, with traditional manufacturing, I've heard of examples where 95% or more of the materials cut away, and you can try to recycle it, but it's essentially it's easier if you could just do it in one piece, essentially.
Sure, absolutely. Look, the Bite-A-Fly is a huge point, and I'm glad you brought that up. So when you take a plate of titanium and you have to carve out 95% of that, you're left with chips on the floor. Those do get recycled, but the cost to machine it's very high. The cost of all that scrap is very high. So now we have technologies that come out where we get near net shape or even net shape in some cases. That obviously allows us to put parts on a plane that have a great Bite-A-Fly ratio. We can incorporate designs that give us a better fuel burn, so that is a cost savings to our customers and environmentally much more friendly. And then you look into the cost side of the equation beyond the scrap, and a huge element would be the supply chain simplification you see. When you can take what were disparate different components, combine them into one, you're really simplifying that supply chain. You're simplifying how many parts you have to have an inventory to support those components. Now you just build one part. You have a machine that's building a part, and we have examples. The fuel nozzle was a 20-to-1 part consolidation. We have many that are 50-to-1. Probably one of our better examples is a 300-to-1 consolidation. And when you start talking about that entire chain, the cost savings to the customer and better performance, the benefits of fuel savings because we can lightweight things, the scrap reductions and the supply chain simplification, you're talking about a pretty compelling number.
Now, GE, since they acquired your companies, they've acquired other companies, including a couple last year. And SME had this AeroDef show 2 months ago, and one of the things was a tour at facilities of one of the acquired companies. Where do you see GE going, in a general sense? I mean, obviously they have embraced it beyond the fuel nozzle, beyond aerospace. Just what's your view of how it's going?
So I think, I know GE really takes a broad view. They take a view of the machines and the technology itself, and you're right, GE has made a few inorganic plays. I would look as we march forward, we will organically grow, meaning we will invest in the companies that we've acquired, we'll invest in the technologies. We will also continue to be looking for inorganic plays. So we will continue to look at the landscape, both in the metal space, the polymers, other materials, but well beyond just the machines. GE has a tremendous ability to bring to the table what we call the GE store. And this GE store consists of things like our GE Capital business, able to bring in financing. We have GE IT inspection, so we're able to bring in CT scanning capabilities. We have uninterruptible power supply through our GE Energy, our Predict software. So we actually look at the landscape much broader than just the machines. We're looking at it from truly, I think, the entire combination of the digital industrial together.
Okay. Any last thoughts?
I would say this is just a tremendous and exciting industry. You look at this show, you see how much it has grown just in the last year, let alone the last 5-10 years. I think we will see explosive growth, and frankly, we look at the industry that's roughly $6-7 billion today in total, and we look out 10 years and we think it'll be at least 10x that. So I would predict that in 10 years we'll see an industry somewhere in the $70 to $100 billion range. That's materials, machines, services, software, etc. But clearly we are on a path to explosive growth. It can most assuredly be considered a disruptive technology, and we're just thrilled to be a part of this ecosystem and really excited to see where the future takes us.
Okay. Thanks, Greg, for your time. Appreciate it.
Thank you, Bill.
This is Bill Koenig with AMM, part of SME, and this has been another Rapid Live interview. Thank you.